Does the size of a creature, or the size of its eye, affect what can be seen by the naked eye? For example, can ants see things we consider microscopic? Are ants microscopic to elephants? Edit. Wow. I was expecting something along the lines of course not idiot, but this is now my top ever post. Great discussion everyone. Also yes, ants don't have eyes, I know that now. I just meant something small that does have eyes. Edit 2. Okay, ants do have eyes. Also, why am I on the front page for asking if elephants can see ants? This is the best day ever. Final edit. Somebody gave me gold, and this has become the third top post ever on ASK Science. That is not how I was expecting this to go. Thank you all. In terms of optics and photoreceptor density, which are the principal factors in a creature's visual resolution, details per degree of visual angle, there probably isn't much real difference between the angular visual resolution of e.g. a jumping spider and a house cat. Both can see, at best, about approximately 10 details per degree. So if you shrank a cat down to spider size, or vice versa, they'd both have similar limits to the smallest things they could see. But since they're different sizes, the sizes of the things they can see will also scale. Since the eye is getting smaller, its near point, I think I meant, depth of field, here, is getting proportionally shorter. So if a jumping spider's eye is 1,000 times smaller than a cat's eye, it can potentially resolve details that are 1,000 times smaller than what a cat's can resolve. A cat can never get optically close enough to a grain of sand to make it a degree wide, so that it could see 10 details on its surface, while this optical distance is easily available to the spider. The caveat to this general scalability of vision is in the noisiness of light, i.e. factors like diffraction, limitation in how small of a point can be focused, or chromatic aberration, the difference in focal distance for different light wavelengths. For a big eye with a big pupil, this noisiness is insignificant, but for a spider's eye it is getting significant, since all of us are looking at more or less the same light bandwidth. Jumping spiders, for example, deal with this by having retinas at different focal depths to try to account for chromatic aberration. But this stuff gets complicated, especially considering that the range in optical quality and photoreceptor density across species washes out most of these limitations. I think you could safely suppose that, in the range of terrestrial creature sizes, vision basically scales with size. Edit. The important thing is that things scale, but my concepts are confused near point etc. See, Craig Dubia for better, more detailed info. Edit. Sorry I didn't keep up with this, was busy all day. But let me excuse the rough edges of my answer by saying it was a lot of well-informed hand-waving, and of course I didn't try to go into detail about diffraction and lens power and etc. I just wanted to get the basic gist across that vision should more or less scale with the size of the eye, receptor sampling being equal, as in the cat-spider comparison. Field of view, pupil sizes, etc., all very important, but another time and place, okay?